Hi, today we are going to practice making equivalent fractions. Here we go. Okay, so here I have a very simple fraction drawn. It's representing 1/2. I always like to think of my circle fractions as pizzas. So I have 1 out of 2 slices of pizza, half of the pizza. Now, if I were to slice this pizza again this way, now I've created 4 equal pieces of pizza. It's still half of the pizza that's shown, but now because of the way I've sliced it, I have 2 out of 4 pieces of the pizza. It's still 1/2. 1/2 and 2/4 are equivalent fractions. Let's talk about some fraction words. The top number in a fraction is called the numerator. The bottom number in a fraction is called the denominator. Now, all equivalent fractions share a similar relationship. If you were to compare the numerators between 2 equivalent fractions, the 2 numerators will have the same relationship as the 2 denominators. So if we look at these two, I go from a numerator of 1 to a numerator of 2. That's an increase of times 2. We're always multiplying or dividing when we're creating equivalent fractions. If I look at my denominators, 2 to 4, that is an increase of times 2. So in order for 2 fractions to be equivalent, you have to have the same relationship between the 2 numerators as you do between the 2 denominators. Another relationship you can look at is, in one fraction, the relationship between its numerator and denominator must be the same as the relationship between the numerator and denominator in an equivalent fraction. So here we see that the denominators are 2 times bigger than the numerators. That makes these equivalent fractions. Okay, here I have a fraction that is, or I have represented the fraction 2/5 because I have 2 out of 5 pieces. Let's call this a chocolate bar. 2 out of 5 pieces of my chocolate bar are colored. Now, if I were to split each of these sections into 2 smaller sections, I have just created 10 chocolate bar sections, and 2/5 is equivalent to 4/10. I can see that my numerators have doubled, my denominators have doubled, so they're equivalent. Okay, let's do some examples of equivalent fractions where we're only relying on the numbers, no pictures. 2/3 equals how many sixths? So let's deal with the denominators because we know both denominators. The relationship here is that I'm increasing by a factor of 2. 3 times 2 is 6, so I have to have the same relationship between my numerators. 2 times 2 is 4. So 2/3 equals 4/6. Here I know my 2 numerators, so let's look at their relationship. 3 must multiply by 3 to turn into 9. So down here I must also multiply my denominator by 3. 4 times 3 is 12. So 3/4 is equal to 9/12. Here I know my numerators. Now notice how I'm getting smaller as I go down. That's okay. It just means I'm dividing. So 20 divided by what will give me 4? Well, that's a division of 5. If you're more comfortable with multiplication, you can go the other way. 4 times what is 20? It's times 5. 4 times 5 is 20. Therefore, 20 divided by 5 must be 4. So you can think multiplication in your head in order to figure out the division. Okay, so since I divided my 20 by 5, I must divide my 15 by 5. 15 divided by 5 is 3. So 15 over 20 is equal to 3/4. Okay, last one, and this one's one of the tricky ones. So I have two numerators here, but 3 times, there's no whole number that I can multiply 3 by to give me 4. So it doesn't mean I can't make an equivalent fraction. It just means that I'm going to look at the relationship between the numerator and the denominator in one single fraction, the fraction where I know both pieces, and then I'm going to make sure that this fraction has the same relationship between its numerator and denominator. So 4 times what gave me 12? 4 times 3. If 4 times 3 gave me 12, then 3 times 3 will be 9. Same relationship between numerator and denominator. So 4 twelfths is equal to 3 ninths. Okay, now it's your turn. Okay, now pause the video, try these questions, and then come on back and check your answers. Okay, here we have 8 over 10 is equal to 4 over what? I see that I am dividing by 2 to change my numerators, so I must divide by 2 to change my denominators. 5. Here I can see that I am tripling my denominators, so I must triple my numerators. 3 times 3 is 9. 3/5 equals 9/15. Here I see I have doubled if I'm going left to right, or halved if I'm going right to left. So since I need to go in this direction, I'll choose divide by 2. 7. Here, I can't find a whole number to multiply or divide each of these numbers to get one or the other. So I'll look at my numerator-denominator relationship in the whole fraction that I have. So I see that to go from 25 to 5, I'll need to divide by 5. So let's do that on this other side. Oops. Divide by 5. 3.